In this video, you are going to learn how to solve exponential growth and decay application problems. When we are solving word problems for exponential growth and decay, we are always going to use this formula. And again, let's remember that A is our initial amount. It's our starting point. R is our rate. It is a percent, but we want to write it as a decimal. And T is time. At this point in class, we are always just solving for Y. Alright, so let's get to number 1. It says a town has a population of 18,000 and grows at 2% every year. What will be the population after 12 years to the nearest whole number? Alright, so they say a town has a population of 18,000. That's going to be our A. That's our starting amount. That's what the population is at that point. The rate's always going to be given as a percent. So that's our R, but we have to write it as a decimal. So 2% as a decimal, we move it over twice. So our R is going to be 0.02. And time is always in years, minutes, seconds, weeks, whatever they decide to tell you. And here it's 12 years, so that's our T. So Y equals A, 1 plus or minus R to the T. Now remember, the plus or minus, we have to determine if it's a growth or a decay. And we can look in the word problem, and it says grows. So that's going to tell us we're using the plus sign when we start solving. Y equals my initial amount, 1 plus, because they're telling you it's growing, 2% is 0.02 as a decimal, and our time is 12. So if I were to plug this all into a calculator, I would end up getting a population of 22,828.35, but we want to round it to the nearest whole number, so our population would be 22,828 people. If we look at the next one, an element with a mass of 420 grams decays by 11.8% per minute. How much of the element is remaining after 16 minutes to the nearest tenth of a gram? Alright, so we know the starting amount is 420. That's our A. The rate at which it's decaying is 0.118 because I moved the decimal over twice. And we know our T, they want to know after 16 minutes. We also just have to decide whether it's a plus or minus. And right here they tell you it's decaying, so it's going down. So I know I'm going to say 1 minus R to the T. Y equals 420. 1 minus 0.118, all to the 16 power. When I plug that all into my calculator, I get 56.33, but they want it to the nearest tenth of a gram. So my 10th place is right here. I look to my 3, and since 3 is less than 5, it stays 56.3 grams. Now, if we look at number 3, $9,000 is placed in an account with an annual interest rate of 8%. How much will be in the account after 17 years to the nearest cent? So $9,000 is our starting amount. That's what was placed in the account. We have an interest rate of 8%. Now here's where you're going to maybe struggle with your percents. You got to move it over 2 decimal places, so it's 0.08. How much will be in the account after 17 years? So if you don't know anything about an account and annual interest rate, you're actually getting money in your account, so it's plus. So I'm just going to replace my A with the 9,000, my rate with the 0.08, and 17 for my T. When I plug that all into my calculator, I get 33,300,1624. But we're talking about the nearest cent, and nearest cent is 2 decimal places. So I'm going to look at the 2. Since 2 is less than 5, my final answer will be $33,300.16 in that account. Alright, our last one. A new car is purchased for $25,000. The value of the car depreciates at 8.25% per year, so that's going to be 0.0825 for my rate. And then what will the car be to the nearest cent after 15 years? So 15 is going to be my T. Once as you pull a car off the lot, the value of the car goes down a lot, so it's depreciating. It's getting lower in price. It's decaying, so we're going to use the subtraction symbol. Y equals 25,000. 1 minus 0.0825, all to the 15 for my T. So when I plug that into my calculator, the cost of that car after 15 years looks like this, but again we got to round it to the nearest cent. So my nearest cent is 2 decimal places, so I look at my 6, and 6 is greater than 5. This is the value of my car after 15 years. Let us know if you have any questions.